everyone, welcome to my channel once again. Today I'm going to talk about finding the derivative of any function using secant lines. For example, let's say we have x squared. So this y equals x squared, and the idea is that I want to find the gradient at this point. Do you get it? So the gradient at this point is different from the gradient at this point, different from the gradient at this point, different from the gradient at this point. Do you get it? So that's the idea. So to do that, we just have to locate a point here, find the gradient at this point, locate a point here, and draw a tangent to touch that place. So let's say we are finding for, let me make it bigger. Okay, cool. So let's say we are solving for the gradient at 1. So all we need to do is to enter the point at 1. So 1 comma f of 1. F of 1 because my function name is f of x. If yours is g of x, you have to take note of that. Alright, so I have my point here. So the next thing to do is to locate tangent. So I come to tangent. So locate this place and then come to tangent. So to do the tangent, you can either click on the function and then click on the point to generate the tangent, or you can click on the point and click on the function. So then click on the function and the point, so it's generated, and we can see it's y equals 2x minus 1. So assuming your equation is not in this form, all you need to do is to right click on it and choose so because it's in y equals mx plus c, I see ax plus by plus c, so you have to choose y equals mx plus c from here. Alright, cool. So the next thing is to find the slope, and we can see clearly that the slope is 2, but all we need to do is to just type slope, and then we indicate the name of the line. So the name of the line is g. I can see the slope is at 2. The slope, and it's defined here as 2. So the next thing is to find secant line. So I can undo this. All I can do, I can clean them. Alright. So the next thing is to find 2 secant lines that will approach this point to see whether they approach the same gradient. So all you need to do is to define a slider for the right side, right secant slider, and then the left secant slider. So all you need to do is to define a slider for the right side and then the left side. So I'm defining a slider. So for the right, I'll type R, and we are approaching 1. So it should be somewhere close to 1.001, and the maximum we can set it to, let me set it to 2.5, it's fine. And your increments can be very small if you want. And then come to animation and choose degradation, since we are approaching from the highest to the lowest. So you see I entered 1.001 but I couldn't find it, so all you need to do is to come to options and choose rounding to 10. Alright, so the next thing is to do for the left, that will be L, and that one too we are approaching, so we can start from -2 and then that one, so 0.999, and my increment is 2.0. So the next thing is to actually define points for the right and then the left. That will be moving. Let me show the point. We are approaching this point, right? So let's show the point. So let's say the right point, r equals, we just type right, so r equals, right, and then type r comma f of r, and then the next point is the left, so you do l equals r comma f of l. Good. So we just have to join them. So I just come here to the line 2 and then choose line, and I'll join this to this, and this one to this. Done. So the next thing is to find slope. So you can see what I'm trying to say. So you see the equation is not given as y equals mx plus c, so you can't really tell the gradient in it. You have to choose this. Alright, click on this one too and choose this. So you can see the gradient of the left changes to that. So all you need to do is to find the right slope and then the left slope. So right slope, you can see it clearly from this that you have to just define slope. So the right equation is this, is h, enter, and then you do left slope equals slope, and then the line is I. So if the line is I, you can see it clearly. So if you move this one downwards, the slope keeps changing till they get to that place to 1.999, which is close to the 2 that we originally had. And this one too, the approach is approaching, the slope is changing, and you can see clearly it's 2.001, which is close to the 2 that we initially had. Alright, so that's how it works, and you can actually approach this. So you can animate it, and you can also animate this one, and they are approaching. So as they are approaching the slide, the points, their gradient keeps changing. Good. Alright, see you next time. Bye.